Welcome back, everyone. In today's video, we're going to jump into a Ret2Win challenge. This one's going to be working on some of the subjects that we have covered in my previous videos. So if you haven't checked those out, make sure to go check the playlist or them linked here in the description. But let's just jump into today's challenge. It's going to be a black box challenge, and one of those items that, let's just see where we are. Right now we are just given this binary. Nothing for sure about it. Yeah, we do have the flag.txt file, and when I downloaded this is from ROP Emporium, a great site for those that want to jump into software exploitation and ROP chaining, topics that we've covered in previous videos. But in this, unfortunately, for some reason, when we do try and capture the flag, it won't actually give us the flag, but I'll show you how we know that we got the correct exploitation to work. But let's just jump right into it. Again, black box challenge, so we're not given the source code. Let's first see what we're dealing with here. All right, 64-bit software, have a trick, and we're using read, so don't have to worry about null bytes. So okay, that's good. Let's just, I don't know, put in lots of H's and just see what happens. Okay, thank you, segmentation fault, and it continued on with all the other H's that were still buffered in, so nothing really challenging there. As we start off with these type of challenges, I like to go in and check out GDB. And so got our Jeff system, our add-on, so we're going to be able to take a look at the stack and everything from that. So let's just see what we're doing here. Got to see what functions. All right, we got main, got pawn me, and then we have the Ret2Win, which isn't explicitly called. And so in this challenge, we're going to have to be basically finding the offset, then inserting the Ret2Win address, and then having it basically execute from that point of view. So let's just see what we can disassemble main, just see what's going on. All right, so we are generating the stack frame, puts, so that's just generating the output that we see on the screen. We're going to call pawn me, and we're going to generate some output at the screen, which is, I think, like exit or thank you or whatever that is. So next thing, let's disassemble pawn me just to see what we're dealing with there. All right, so generating the stack frame, load effective address, puts, print, and then there's our read, and that's where our basically our buffer overflow is. And so we're going to have to go in and check that out. Pattern search. So let's just first, I always like to break on main. Pattern. What is it? Generate. Create. Pattern. Create. All right. So again, as we've talked about before in previous videos, what we do, we generate this unique pattern, and let's hit continue. Run, and then continue. All right, so let's have the input. All right, so again, this is undefined command because that's all the extra buffer, but that's the part that we don't worry about. What we're most interested in is right here, and as you can see, this is the hex equivalent to number of I think what would be little a, and so forth. So this is really corresponding to, as you can see right up here in the base pointer, all of these, but we're interested in this at the very, very top of the stack to see what potentially our offset is. So we will pattern search on, did I grab this, because we want to make sure that that's what we're going to be providing. And you could provide it as this. Traditionally, what we've done in previous videos is actually whatever is on the stack, and usually it is the ASCII letters, but in this instance, it's the hexadecimal equivalent. So, all right, so it's telling us that it's likely 40, and I'll be able to show you here in a second and confirm that it is Little Indian. So let's, all right, we have the ability to actually start building our little pawn tool script that we're going to use to overflow and get to that Ret2Win function. All right, so let's just start with nano Ret2Win.py. All right, from pawn import star. All right, our offset is 40, and as I mentioned to you a little bit earlier, we want to confirm that a couple different things, and the best way to do that is one of these this elf functionality that's provided in the pwntools tool set, and I'll show you why here in a second. So let's just do Python 3 Ret2Win. And what was our error there? Because let's see here. I forgot the dot, of course. All right. So what this shows you here is the architecture, Little Indian. No stack canary, no cookie found, and that's actually going to be our one of our next videos that I'm actually creating right now. No pi, which is basically deals with the instruction, a little bit of the offset. So and also the stack execution is enabled. So we're going to be able to put basically our address onto the stack and have it execute. And yeah, so like I said, we're gonna go back. All right, we don't need that anymore, so I'm going to comment that out. Next thing that we are going to want to look up is the address for what we want it to jump to. So again, we're replacing what the stack pointer is. Okay, yeah. This is something you do once you actually get to run it. So let's just quit out of that. Let's quit out of this, because that's crazy how everything just jumps out at you like that after you've run it. The address that we're most interested in is just Ret2Win, because as we went through main and pawn me, hey, those are not those do not include a call to Ret2Win. So the address that we're going to be wanting to put in is basically the straight address of Ret2Win, which will include a system call, and it's supposed to be a system call of bin shell flag.txt. And I'll just show that here so that you can see that disassemble Ret2Win. All right, so we have that puts. It's basically a congratulations. Here's the flag type of comment, and here's the call to system. We'll just be able to see this, which will be an indication enough that we have actually reached it, because it'll say, thank you, here's your flag, or something along those lines to that. So minimize that. So we have our address. So we're really, set to go here. And so we just need to connect this to a process. This is the Ret2Win. So we know what it needs to create, basically create another process, Ret2Win. Now, here's what this is. Basically what we're going to be doing is our trusty little A's. So we're overflowing everything right up to the return address. We're overriding the return address from what it wants to go to what we want it to go to, which is Ret2Win. So, but in order to do that, we're sending in this overflow, and it's going to be 40 because we found that to be that offset. Now we got to pack it, pack our address, and always we want to end with interactive, and that really should do it to what we need it to do. We have our offset that we found based upon the pattern generate and search. The address, which is Ret2Win. We start our process. We then send in the amount of we want to send in A's, a whole buffer of A's, to overflow everything right up until that return address, and then lay down the return address that we want the stack to return to. And then finally interactive. So let's just make sure that that works. And clear everything out here. Python 3 Ret2Win. Perfect. And as you remember early on, this was the generate the puts that putting the code here. Thank you, and then well done. Here's your flag. Again, fortunately, we don't have the flag. We do have it locally, but and I can show you there. But this does show that we actually got Ret2Win. Now, truly appreciate you. Actually, we can go and check, and let's just pretend that we did that. So, yep, there it is. Placeholder 32-byte flag. So, thanks for joining. Make sure to hit like and subscribe. Look forward to our next video. Thank you.